right then, we've got another few seconds, but we may as well get going. We've got a lot of stuff to get through today. So I'm Chris Saxon. I'm part of Stephen Feuerstein's Oracle Developer Advocate team. It's my job to help you get the best out of the Oracle database and hopefully have a little bit of fun while doing so. So with that in mind, today I'm going to be talking about some of the cool, new, exciting stuff here in 18C to help you build better, faster Oracle database applications. Standard disclaimer before we begin, let's get started. Now at this point, some of you might be going, hang on a second, 18C? Wasn't the last version 12C? What happened to versions 13 to 17? You know, have I fallen asleep for 10 years? Has Oracle gone into a time warp? What's going on? What's happened here? Well, the good news is you haven't missed anything. This is a part of a new release schedule. So every year there's going to be a new version of Oracle Database. And the number of that version is going to be the last 2 digits of the year. 18C this year, 19C next year, 20C the year after that. Want more details, you can have a look at that MOS note. So the good thing is you're going to get more features quicker, and there's going to be fewer things in each release, which is going to make these kind of end things about version end talks a little bit tricky. So I'm going to cheat a little bit. For most of 18C's life, it was actually referred to internally as 12.202. So I might cheat a little bit and steal some 12.2 features in this talk today. That's enough of that. Let's talk about some technical stuff. So we'll start with external tables. I really like external tables. They're a fantastic way to read files into your database using SQL, but they can be a bit fiddly to work with. Quite often, a common use case for external tables is when you've got imports from extracts from an external system, and they are daily. And the files you get from that other system are stamped with the date in them. And this is a bit tricky to work with. Either you can munge the file name, so convert it from the date to a standard name and then archive it off afterwards, or you kind of go through a process where every day you repoint the external table to a new file, which is a bit tricky to do, particularly if they haven't just stamped the file with the date, but they've included the full time as well, down to the hour, minute, and second. So it's the exact precise time it was generated, which makes it difficult to do this kind of repointing in advance. So this is a bit of a faff to work with. Luckily, in 12C, we had a nice little feature which made this easier to work with, the external table parameter override. And what this allowed you to do is change some of the settings for an external table at the individual query level. And one of the key ways it could do that was actually change which file it's pointing to. And you do that with this external modify clause. So you can point it to a new directory, say it's pointing to a new file, change the log files and so on, and the reject limit. So if you're in this situation where each day you've got a new file name that you're pointing it to, you can go through like this. The first day we external modify, point it to the 1st of January I've got here, the next day 2nd of January, and then the 3rd of January, and so on. You can do this with bind variables as well. You don't have to paste the full name in there. So that's much easier. This is something I wish had existed about 10 years ago when I was doing a lot of CSV file importing. But we've got it now. So this is great if all that's changing is the file name, but sometimes there's a bit more to it than that. So sometimes not only does the file name change, but actually the contents of the file changes as well. So for example, at the weekend, you might just get one file for the weekend which combines Saturday and Sunday's data, and then you've got an extra column with the date in it. Or maybe month and year end, they have some extra summary information. And this becomes quite tricky to work with because potentially you've got different definition. You want to expose different columns from your external table based on the date. And this is tricky to work with. You know, do you create different external table for each day? What do you do? And one approach is to kind of take the cop out and say, we'll put everything into just one big string. So we'll just read all that, each row at once into the file. So we get everything there together like this. So that's great. We can read the data into the database, but we've still got a challenge, right? How do we actually split those values out? How do we convert those into columns? And this is where things get really messy in Oracle Database. You can kind of go to substring hell and try and figure out exactly how to pull things out. Feeling really brave, you can play with regular expressions. Neither of these are particularly great or fun to deal with, and they still leave the problem that you've got a fixed column list. If you want to actually change which columns are appearing in your output based on the file, it doesn't solve this. So in In 18C, however, there is a new feature which allows you to actually manipulate which columns appear in your output dynamically, and that is polymorphic table functions. It's something some of you might have heard of. And what this does, as I say, is allow you to change, add or remove columns from your output. So for example, we can have this CSV to columns polymorphic table function. We're passing in the table name and which columns we want to appear in the output. Want a fourth column? Well, we just add that, and now we get 4 columns in our output. So we can dynamically add or remove columns from our output based on what we're inputting. So how does this work? How do you do it? Well, there's a couple of things you need. First up, you need to create a package. So this is kind of the engine for your PTF. And that has a couple of things within it you need. First up is a describe function. This tells the database which columns will appear in your output, so you can add or remove them as needed. Next is a fetch rows procedure. Technically, this is optional. Technically, you don't actually need that. But this is how you assign the values for each row for these new columns. So I struggle to think of a real-world case where you wouldn't have this. But there we go. So this is, like I say, is the implementation of the PTF. Then to actually call it, you need to create the function itself. You can do it within the package, or you can create a standalone function like this. And we see we're using that package. So we're binding it to that package we've implemented, and it will pick up the implementation we've got for it. So this is a big feature. To fully understand it was a talk in its own right, so I'll just go through a very quick example. So let's say we want to add 3 columns to our output. That's all we're going to do. 3 columns that are going to have null values in them. We can do it with something like this. So we've got this new DBMS TF package, and we're adding some new columns 1, 2, and 3. That's all we need to do in our package. I then create a standalone, the PTF function itself, called add 3 columns, and when we pass in dual, we get 3 columns in our output. Like I say, this is a very basic thing, just to give you the kind of idea. Read more on the docs. It's a very big feature if you want to actually play with it in detail. So that's polymorphic table functions, and some of you might have noticed something a bit interesting in my implementation here. And that's these values here. What are these 1, 2, 3 here? Well, they can't be parameters to a procedure, because parameters must be identifiers, and unquoted identifiers have to start with a letter, right? In Oracle database. So what on earth are these numbers here? What's going on? Well, this is something else we've introduced in 18C, and that's qualified expressions, also known as array or record constructors. So what this allows you to do is initialize records or associative arrays in one call. So if we compare what we had to do in the past, we've got our table indexed by varchar2. If we want to initialize this with 3 variables, we'd have to do something like this. So we're kind of doing a lot of typing here, duplicating things. We now have an implicit constructor for that type. So bool VC array is also a constructor, and we can do something like this instead. So it's a single call to initialize everything in one pass. Nice little simplification feature. Like I say, this also applies to records as well. So if we've got a big, long record with lots of attributes to it, in the past, you'd have to go through and assign them all individually. Well, we've now got the implicit constructor for that too. So you can do something like this. So nice little simplification feature, potentially useful when you're setting these up. But we've kind of gone off on a diverged a bit from where we started. We were talking about external tables and how we get different columns on the output. And at this point, some of you are probably going, what are you doing here, Chris? Talking about PTFs, messing around. This is just nonsense. You're going crazy here. I'm just going to stick with dynamic SQL. Well, if you want to manipulate the columns in an external table, there is another new option in 18C, inline external tables. So these are external tables which literally only exist in your query. So you do that with this external clause. So this is not a table, external. That is telling the database that on the fly, we're going to generate an external table. And you can literally paste it in. So you say which columns you want and which file it goes to. So we can do something a bit like this. So we have a column, we're going to a text file, we're going to add another column, and so on. So we can do this on the fly. Potentially very useful if you kind of do a lot of ad hoc data analysis on different files. Also, it can be tricky to figure out the exact access parameters for external tables. If it's not a straightforward CSV or it's got carriage returns, you can spend a lot of time trying to mess around with it. This allows you to kind of prototype it, figure out the exact definition without having to go through the drop and recreate the table every single time. So you can just figure out how to build it, get it, and then build the real table later. So this is all good. We've got our kind of dynamic, on-the-fly external table, but this is data. We're reading it into the database, so we want to store it into a table at some point, right? And I'm being lazy. I don't want to specify the columns there, but the columns in the external table can change. So, what do? How do I list the columns out here? I want it to change dynamically just based on what I've changed my external clause here. Well, there's another new thing we can do in 18C, private temporary tables. So these kind of extend the concept of global temporary tables. And they do this with this private temporary table syntax. And notice there's this lovely or a $PPT underscore prefix. You have to include that. And that must match whatever this parameter is set to, your private temp table prefix. That is how the database knows that this is a PTT. Now, the interesting thing about this is it literally only exists in your session. So if you try and query the data dictionary, so user tables, user tab calls, or whatever, you'll get nothing back. You won't see it in the data dictionary. You can only query it in your session. And also, interestingly, if you've got two sessions concurrently, they can have the same PTT with different columns in them. So they can each have a different output. So you can create it, read and write from it. Any of you who've come from a SQL Server background might be more kind of familiar with this. They've had this for a very long time. So we can put the data in, insert it, and it's there until we come to commit. And at that point, if you try and query it, what happens? Table on your view does not exist. Why? Well, a bit like global temporary tables, there is an on-commit clause. And by default, we drop it. So at the end of your transaction, it'll go. If you don't want that, if you want it to persist across transactions, change that, set that to on-commit preserve definition. It will still disappear once your session ends, but at least it will preserve across transactions. So this is all very well and good. We're talking about kind of dynamically working with our data and so on. But what a lot of people, or some people do, rather than trying to model this relationally, is go with JSON instead. So they go, oh, we know we're going to have different attributes and so on. We'll just stick it in a JSON document and deal with that. So what I'll do is just give you a brief tour of JSON Oracle database, starting with 12.102. So here, we introduce some functionality to help you when you're storing a JSON document directly in a column. And this, one way we did this using this is JSON check constraint, which allowed you to do things like simple dot notation access to get the elements out. So this is all very well and good, but we got our employees JSON, and the employees were an array within the department. And good chance at some point you'll want to convert that to a kind of traditional relational format, rows and columns. But we've only got one document, so how do we do that conversion? Well, again, in 12.102, we introduced this JSON table function, which allows you to do that mapping. So you can explode out all the attributes, all the elements of the JSON array into individual rows and columns. So this is all very well and good, but it's a bit kind of clunky, quite verbose really, isn't it here? You can see we've doubled up on a lot of stuff. We've got column names that we're going to have in our output exactly matching the attribute names, which kind of breaks one of the key development principles of don't repeat yourself. We don't really want to do that. This is clunky and messy. So in 18C, we've simplified this. You can just get rid of all that path nonsense and do something like this instead. And now the database will infer the path based on its location in the JSON object that you're referring to. So all you're doing is having columns that exactly match the attribute names, much more simple, much more straightforward. So that's if you're storing JSON directly in the database. But personally, I think most of the time, you should actually be shredding your JSON documents and storing them relationally. But then that brings the opposite question. Well, we've got our relational tables. How do we get the data out in JSON format, right? And to do this for anything beyond the most trivial of JSON documents is tricky. So in 12.2, we introduce a whole bunch of JSON functions to help you do this, JSON array and JSON object ones. And what they allow you to do, so the array will give you all the elements, and an object will wrap it in the curly braces. So this is cool, but in 12.2, it was a bit limited. We didn't support all the various data types and so on. 18C, we've kind of finished off the implementation here. We've gone on, so now we support all these data types as input, and as the return type, you can return a glob or a blob. So again, we're just kind of gradually finishing off in the implementation of all this various JSON stuff. So this is all well and good, but if you are taking a JSON document, shredding it into relational tables, it's almost certain that at some point, you're going to want to query that same document back out again, which leads to an interesting question. Are these documents the same? Now, you're looking at that and you're thinking, they're not the same. But as far as the JSON standard's concerned, these are. You know, all that white space, it doesn't care about. And although I've got the department at the top of the document on the left and the bottom of the document on the right, attribute order does not matter to the JSON standard. As far as the JSON standard's concerned, these are the same. So how do you validate that? How do you check that these are the same? Not an easy thing to do. So in 18C, we've introduced a new condition, JSON equal. Nice and easy, pass it to JSON documents, and it will tell you whether or not they're the same. So we can do something like this. Note, I've also got this new treat thing. So we're saying, telling the database, this is actually JSON, or consider this to be JSON in the string here. So we've got those two, passing it to JSON equal, and as I said, it ignores insignificant white space and attribute order. So first glance, these appear different, but they are in fact the same. So making it nice and easy to work with these JSON information. Check what's going on. So let's move on. Common reason people want to store JSON objects in the database is things like IoT devices, Internet of Things. So you've got these devices, hundreds, thousands, maybe millions of them, and they're just constantly sending JSON payloads to your database. So all you want to do is dump it in your database and also give it a sequence-assigned primary key. That's all very well and good, but if you've got, as I say, thousands, hundreds of thousands, millions of these devices all throwing data at your database, you can have some contention issues. Actually getting them in can take a while. First up, you might have some contention on the sequence itself. So everything trying to access individual sequence. You can help reduce this somewhat by having a huge cache value, but potentially there's still issues there. But there's another problem as well. So we've got our primary key, we've got the index for that. Because these sequence values are always increasing, all the new rows, all the new entries are going to go on the right hand of that index. So everything's trying to go in one single place in the index. We're going to get a lot of contention there. We want to avoid this. We don't want everything going in the same place because we've got everything trying to access one block. What we really want to do is spread the inserts out across the index, making it more likely we can get the kind of throughput and concurrency we want. Now, there are techniques to do this, such as reverse key indexes and hash partitioning your index and so on, but these both come with their own drawbacks, and they require you to rebuild the index, which is not the kind of thing that gives you a nice, warm, fuzzy feeling on your 10 billion row table that's having data pumped into it. A lot of people kind of try and hold off doing these things as absolutely long as they can because, it's risky, it's scary, right? Don't want to do this. Well, in 18C, we've got another approach which can help with that, and that is, if I can go on, scalable sequences. As my colleague Connor pointed out, an interesting name. We always thought sequences were scalable anyway, but there we go. So what this does is it introduces some new clauses to the sequence when you create a sequence, scale and extend. So what does that do, and how does this help in any kind of meaningful way? Well, when you specify scale, what the database does is generates a 6-digit prefix for your sequences. So we've got this value here off on the left, and that is generated from your instance if you're in rack and your session offset. So 2 sessions are very unlikely to have the same starting prefix. So they're going to have different values, more likely to spread them throughout the index. And the actual sequence values come down here. So we get the values. So essentially, we're padding it out up to and applying 6 digits. And if we've done it with extend, those 6 digits go on top of whatever the maximum value of your sequence is. If we change that, say it's no extend, those 6 digits go within the max value of your sequence. So interesting thing to note here is the max value of your sequence must be at least 7 digits long now, because you've got to reserve these 6 digits. And if all you do is make a 7-digit sequence number, you only get the values 1 to 9 out of your sequence. So this probably isn't going to be too much of an issue for most of you, but if any of you got like max value set on your sequence and you're using it to cycle round or something like that, just kind of watch out for it. So something to be aware of. So the good news here is we kind of alleviate it, we stop the contention on the sequence itself, and we're spreading the values inserted throughout the sequence. So we can get the data in, improve our data ingestion. But we still want to get the data back out, right? Still going to query it all back out, and we're going to do that by primary key. And again, this is something where there isn't a huge amount you can do. We're doing a primary key lookup. It's already as fast as you could get. Now, there are data structures like single table hash clusters, which allow you to improve the performance of this, but a bit like reverse key indexes and so on, require you to rebuild the table, come with their own drawbacks. Not the kind of thing that gives you a warm, fuzzy feeling and you want to do on your production database. So how can we improve this? How can we get this faster? So 18C, we introduced something called the Mem Optimized Row Store. And to use this, you just alter the table, do Mem Optimize for read, and then load the table into it. So what is this? What's going on? Well, this is a reserved area of your SGA. So notice if you want to use this, you're stealing memory from something else. So bear that in mind. So how does this help? How is this any better than, I don't know, using something like the keep pool or something like that? Well, the Mem Optimized Row Store actually has 2 areas within it. 3/4 of it is reserved for the table data, and 1/4 of it has a special in-memory hash index based on the primary key. So that can improve the data access lookup. Hash-based access, better performance than the B-tree lookup. But it actually gets a little bit better than that. So typically, or in the past, when you execute a SQL statement, what the database has to do is send that through the SQL layer to actually parse it, figure out what's going on, so on and so forth, and then hopefully get the data out of memory and then return it back to you. With the Mem Optimized Row Store, what the database is able to do is bypass it completely using something called a remote direct memory access. It is literally just reading directly from the memory those values in the Mem Optimized Row Store. So this can help improve performance by up to 1/4. Sounds great. What's the catch? Well, it's Exadata only. So unfortunately, not all of you are going to get to play with this. If you are lucky enough to be on Exadata, how do you know you're using it? We see these read opt-in things that appear in our execution plans. Do note, as well, it only works for equality queries. So you can't do where primary key is greater than 10 or whatever, or less than, or between these values. Only ID equals some value. Any other queries against the table will go through traditional access methods. So specialized use case, but potentially useful for some others. Let's stick with performance and go back to external tables. Let's say you've got a humongous CSV file. It's got like 10 million rows or something in it. And you actually only want a subset of that data. Now, this is a problem with external tables because there isn't much you can do to improve the performance. You can't create indexes on external tables, right? So, they're outside the control of the database, which means that you've got to load the whole file in just to get the information you want, which is a bit of a pain, not necessarily great. 18C, you can now load this into the InMemory Columnstore. So you can do this, populate it in. How do you do it? Again, nice, straightforward. alter table in memory and populate it in. Do note again, you have to have the in-memory option to do this. So you do this, you populate it in, and you run your query, and you find that, well, hang on, we load it into the InMemory Columnstore. Why are we still getting a traditional table access full, external table access full? Where's this nice performance gains you promising us, Chris? Well, as I said, remember that the external table, the file, is outside the control of the database. So someone can come along and just edit it at any point, and the database doesn't know that. It doesn't know that someone has added a row or deleted a bunch or changed some values. By default in Oracle database, we take the approach of you always want the most up-to-date, correct, up-to-date version of your data. If there's any chance that the underlying data might mismatch what the query returns, we don't allow that. So we're not going to go to the in-memory column store because what's in there may not match what's in the actual file itself. So, so what is the point of this? How do we get around this? Well, there's a feature that's existed for quite a long time now, which says, it's all right, Oracle, trust me, I know I want this potentially out-of-date information. Either I know it's up-to-date, I know no one's edited that file, or I don't care. I prefer the performance gains I'm going to get by reading it from the in-memory column store. And that's this query rewrite integrity parameter. So this is something that we've used for materialized views for as long as I can remember. So we can do that, and now we got this nice in-memory access full. Fantastic. We've got nice improved performance. Unless, of course, someone, clever person, decided to stick a no in-memory hint in there. And of course, hints are not suggestions. They're not like saying to the database, by the way, will you please, not use the in-memory column store. It's, you must not use the in-memory column store. Hints are directives, not suggestions. So, and if this is code that you don't have direct access to control, what do you do about it? Let's say it's a third-party application. BI tools in particular, quite fond of doing things like this. How do you get around this? Well, there is another way to avoid this. So 18C, you've got the ability to ignore optimizer hints. So you've got code that you can't change easily, like say maybe it belongs to a third party, maybe it's just some legacy code which no one dares touch. How do you avoid this? You can now alter the session to ignore optimizer hints, and it will pretend that they are not there. So you do that, alter the session, and we get the nice in-memory access full. Got the performance gains we wanted. So we talked a bit about performance, something a lot of people care about. Let's move on and talk about security, hopefully something that we all care about. How do we keep our data safe? How do we stop people hacking in and getting what we don't need? And one of the key ways to do this is follow something called the principle of least privilege. Give users as few permissions as they need to do their job, and only the privileges that they need to do their job. And the way you do this with your application, so you've got your application, you connect to the database as a user that owns no objects. Why does it have to own no objects? Well, you've always got full permission on your own tables. You can always query whatever you want from them, insert, update, delete them, and if you're feeling particularly mischievous, drop them, right? So you don't want someone to potentially be able to hack your app in some way or another, get in and start fishing around. So you want to limit their access, and do that by putting the tables in another schema, and ideally having a PL SQL API to only give you exactly the control you want. So this is all very well and good. We stop people getting in the front door, but there's still a back door, right? We've still got SQL Plus access. If someone manages to get the credentials to our data owner schema here, they can still get in and do whatever they want, right? How do we stop this? And this isn't an easy thing to solve. Now, what you can do is lock the account. So people, they'll try and log in, but they'll get rejected. But that's one of those, it's easy to say, but in practice, is also really easy to overlook. Let's say there's some emergency Friday afternoon. You've got to go in, make some changes in the data schema, and then you forget to lock the account when you're finished. And then all weekend, you're exposed, potentially. A particularly clever hacker might try and engineer a situation to do something like this. So this isn't good. It's an easily overlooked situation. And potentially there's another problem. When you lock an account and you try and connect to it, doesn't matter what password you put in, you'll be told the account is locked. We go, well, why does that matter? Why is that a problem? Well, I now know data owner exists. I know that's a schema in the database. And of course, something called data owner sounds, like it might have useful information in it. You might go, well, people aren't going to enumerate all the possible schemas. This is also a way to find out if you've got things like Oracle Text or XMLDB or Spatial installed. These are things which traditionally have had some of the more interesting exploits available to them. So if I'm a hacker and I can go, wow, he's got Oracle Text installed, maybe I can see if these vulnerabilities apply. So we've kind of leaked some information out here. So we don't want to allow this. We want to prevent these problems. So in 18C, we've done this with schema-only accounts. So these are users which literally have no password. There is no way to log into these users. So how do you do that? Well, you just create the user with no authentication. You see, we've got no password, no way to get in. And if we do that, if we try and connect to it and we pass in some random password, we've now got the invalid username or password error rather than any kind of account is locked or user doesn't exist. We don't know what we've got wrong here. We don't know that the password's wrong or the user's wrong. So we're limiting the information we're giving to the anyone trying to hack around and get into our application. So this is all very well and good. We've stopped any of the bad guys getting into our application, but some of you are probably thinking, well, I need to connect to that schema, right? How do I deploy my, create my tables? How do I run my release scripts? How do I get into this schema without then, re-authenticating it, giving it a password, and opening up this loophole? Well, you can still connect through it using proxy users. So you can create a proxy user and allow yourself to connect to it. And we're actually connecting using the proxy user credentials, but we're running with the privileges of the data owner. So all this create table, whatever else it's got, we can do that. So this is all very well and good, but it introduces a couple of potential issues. First is, so you've got your DBA team or whoever it is who's deploying scripts. They're all coming through this same proxy user. Well, a couple of problems here. First up is how are you sharing these passwords? How are you making sure everyone knows what the password is? Hopefully you're doing something a bit more secure than this. Hopefully you've got like a nice password manager and some secure way of sharing that. But there's actually another problem as well. Assuming we've got an appropriate way of sharing this password, well, we don't know who's connected as this proxy user. So if someone comes in and does something they shouldn't have done, dropped some tables, deleted some data, who knows what, the whole DBA team can kind of go there and go, well, you can't prove it was me. You don't know which of us did it. I'm fine, right? You can't fire me. So we've lost the identity. We don't know who does what. So you want to avoid this problem. You don't want to allow this. You want everyone to come in as their own proxy user. So now you've restored the kind of identity, the authentication, so you know who does what. So that's all very well and good, but then in some ways we're kind of potentially making the password problem worse, because then it's up to every individual to remember their own passwords and manage it in their own particular way. And you don't want this. You don't want people to have to start writing post-it notes down or whatever it is. We want to avoid this. And this is just a general problem here in IT, isn't it? Password overload. I've absolutely lost count of how many passwords I've got, but it's well in the hundreds. People just struggle to managing them. So you want to limit how many passwords people actually have. You want to reduce those down so they don't have to know something new. And chances are, if you're a reasonable-sized company, you've already got something which everyone has, which there's a password they're supposed to keep safe, secure, not share, and so on, managed by your company's security policies, and that's Active Directory. That's how everyone logs in and authenticates, and you know who everyone is. So it would be kind of nice if you could authenticate against that and not have passwords managed in the Oracle database. Well, you can. You can have this lovely thing called Oracle Directory Services, which sits between the database and AD and does that mapping for you. Now, that all sounds well and good, but it's another thing to set up and configure, another thing to manage, and it's just generally a bit of a faff, and people don't really like doing this. So 18C, we cut out the middleman. You can now do direct Active Directory integration from the database to AD. So if we go there, we can cut that thing out the middle and just map things like that. So now you can do all your password policies, security management in AD, and map those to appropriate users and roles and so on in the database. Hopefully simplifying things, making your application more secure. So we talked about security. Let's move on, talk about something completely different. Let's imagine you build some kind of retail web store, and it sells books. So what I want to do is I go on the website, and I want to buy some Oracle books. So it comes back, and we get the results and a whole bunch of books. So that's all very well and good, but if you are a large enough retailer, such as a company that begins with A I'm not allowed to mention, there's going to be a whole bunch of other products with Oracle in the name that search matches. So there's a whole bunch of films, TV programs, music, computer games, and a whole bunch of weird products. There's like unicycles and extractor fans and all sorts of weird nonsense, which includes Oracle in the title. But you want to allow people to help them navigate their search. So you want to show these categories down the side. You want to show all the category, you want to show the categories and how many hits their search got, so you can help them surf this. But of course, I said, if you're a big enough company, you could have a really long tail, a huge number of these different categories. And you don't want to overload the user. You want to limit it to the most popular, the ones they're most likely to actually be searching for. So we want to do a kind of top-end query on this. So how do we do this? Well, it's kind of a two-step process. First thing you've got to do is count how many things match the search for each category. So we get that count, nice and straightforward, and then just do a top-end query like this. So we get in the first 4 rows and so on. So that's fairly easy to write. We're getting, limiting it to the top 4 categories by however many of them include Oracle in the title. But there's potentially a problem here. So if you look at the execution plan, we've got this hash group by step here. Go, okay, what's the big deal with that? Well, if we're processing, if it processes a large number of rows, that hash group by step there might have to start writing data to the temporary table space, which means reading and writing from disk. As soon as you're reading from writing from disk, query performance is going to drop drastically. And the real issue here is, as a developer, you have very little control over whether this happens or not. If you know it's a possibility, you can be really creative with SQL statement, but in general, you have to really stay on top of your data to do this. So in 18C, we've introduced approximate top end queries. So this is a way around this problem. So now, instead of a count star, you can do an approx count star. But there's a bit more to it than that. You also have to include this having clause. So like I say, it's an approximate top n. So we're limiting it to the first 5 rows for each count. And how does that help us? Well, if we go to the plan, and as I say, that's mandatory. If we go to the plan, we've now removed that hash group by step. So we're doing one less thing. So less things we do, everything's going to be faster. Also, we're much less likely to have to write to temp because we're only returning 4 rows. So potentially a nice little feature. But there's a couple of issues with this. So it's approximate, typically over 99% accurate. But for something like a filtering thing like this, it's probably good enough. For your company financial reports, no, I wouldn't use this. Go for exact processing. But thing is, when it comes to product search filters, chances are there's a lot of other things we want to allow users to filter on. So we want to be able to show how many products of each rating there is, or when they were first published or released, who the manufacturer/author is. There could be a whole stack of other types of filters that we want to show. So that means running a different query for each of them. And for some of those, we don't want to sort them by the count of the results. We want to sort them strictly by value. So customer reviews, for example, we don't want to sort the values here by whichever is the most popular. If 7 stars is the most popular review, we don't want to show that top. You want to go strictly from 10 down to 1, or 10 down to however many you're actually going to show. And Approximate Top End doesn't really support this, or there isn't an easy way to do this. So we've got a couple of issues here. One is we got potentially several of these queries we're going to run, and some of them we want to sort by value rather than by count. So how do we do this? Well, there's something else in 18c which can help us, and that is faceted navigation in Oracle text. So this is something new that's coming in Oracle text, and it allows you to kind of specify groups on your data and get that kind of information out. How do you use it? Well, you just got to go through the nice, easy context query result set thing, build up a nice, simple XML request like this, say we want the top 3 products by count, top 3 ratings by value, and then you get a nice, simple XML as a result. So we've got the individual rows and their actual values. Okay, maybe not quite so straightforward. You've got to fiddle around with XML, but it is one request to the database. And another thing is we're actually getting exact counts, or we can get exact counts out of this as well. So potentially useful. If you are like some kind of retailer and you need to show all these different groupings or categories for help people navigate it, potentially very useful. So hopefully, at this point, you've seen at least one or more than one thing you think, that's kind of useful. I could use that. I can see how that would fit into something I'm doing. But, how can I get my hands on this? How can I actually start using 18c? What can I do? So currently, it is only available on Exadata and Oracle Cloud. Now, I understand that most of you probably are not in that situation, not cloud customers and don't use engineered systems. The on-premises release is due in July. So a little while to wait, but not too long. So what can you do in the meantime? Well, we've got this lovely tool called Live SQL. So free, browser-based tool you can use to log in and run SQL scripts. We've upgraded that to 18c. So that is running 18c now. We've also got a whole bunch of example scripts in there. So me, Connor, and various other people in Oracle have built some scripts demonstrating this functionality. So if you wanted to see how I actually did that CSV columns converter, you'll see it's right in the middle, that PTF. So you can start fiddling around, playing, and see how all this works. Not everything works, by the way. External tables, not available. Well, obviously, you've got no access to the underlying file system. But most things are. So you can start having to play around and fiddle and see what works. So that was about 17 things, depending on what you consider to be a feature and whether you consider it to be part of 18c or not. So there's just one final thing I wanted to cover. So at some point, all of us have had a query like this. It's a query that's really slow. You've hit go, and only to be stuck by the spinning wheel of doom, waiting for it to finish, and you're there waiting and waiting and waiting, and then you just start mashing the escape key or something, and SQL developer just locks up, and you're stuck, and you have to go and complain to your DBA and go, please, this query just won't finish, please just kill my session. And they come through and kill your session. It's done, and then you have to reconnect and set up all your session settings again. It's just a pain and a faff. So 18c, we've got another way around this. You can now cancel an individual SQL statement. So if you've got that runaway SQL query, rather than having to kill the whole session, you can cancel it individually. How do you do that? Very similar to the way you would kill a session. You find the SID and the serial number, pass it to an alter system, cancel the SQL statement, and instead of killing your session, you'll get the 1013 user requested cancel of operation error. And at that point, it will stop, and you can continue going on about your business. So at that point, I will stop. Thank you all for joining me. Really hope you enjoyed this. More importantly, I hope you learned something. I'm Chris Saxon. Thanks for joining me.